So now we're going to turn our attention to looking at the gains to the economy as a whole from offshoring, and then thinking about what happens to those gains if the terms of trade move in favor of or against the home country. In order to do this, we're going to take a somewhat simplified model. And the simplification we're going to make here is that we're just going to focus on two stages of production. So we're just going to have R&D and components production. Just to keep it simple. It doesn't matter. You know, we could do any two stages. Right? We're just, one is going to be the more skill-intensive stage of production relative to the other one. So here again, we're going to use a familiar tool in the production possibilities frontier. But we're going to think about it a little bit differently. Right? Up to this point, you're used to thinking about the PPF as representing the combination, or all combinations, of the two consumption goods that society can produce given technology and resources. Well, similar interpretation here, but the two goods in question, instead of being, say, final consumer goods, are going to be R&D and components. And to be consistent with the way the textbook presents it, I'm going to put R&D on the y-axis and production of components on the x-axis. And so now here when we're showing our PPF, what are we showing here? We're showing, given all of our inputs, right, our, in this case, skilled and less skilled labor, and our production technologies, these are all of the combinations of R&D and components that society can produce. And they're going to be used to make a final good. Right? So now when we're looking at our equilibrium, and before, up until, or at least up until this point, what have we had when you're looking for the optimal combination of goods to be produced? We were looking for that combination that yielded the highest level of utility for the consumers, right, for the households. Well, now what we're looking for is the combination of R&D and components that yield the highest level of output of the final good. And so here, instead of an indifference curve, we have an isoquant. Okay? And much like our indifference curve, right, so the isoquant shows us all of the combinations of the two goods in our graph, in this case R&D and components, right, all of the combinations that yield the same level of, in this case, output. And so to use the same labels as we have in the book, right, so use Y, right, for output. So Y, right, this is Y0, that's the level of production of this final good here, okay? So this is, given our production technologies and quantities of skilled and less skilled labor, right, that's the PPF shows us all the combinations of R&D and components we can make. And then we look for the point of tangency with an isoquant, which, as I'm just drawing for you, we'll say happens here. And that gives us the highest level of output of the final good that can be achieved at Y0. Okay? So much like with our indifference curves, we're looking to go higher up, right? Higher isoquants represent higher levels of output, clearly, right? So it shares those features with the indifference curve. In some ways, it's kind of easier to think about this because, clearly, if I can produce 50,000 automobiles over 40,000 automobiles, hey, that's just, right, that's more automobiles. It's not as abstract as thinking about notions of utility, which can sometimes cause problems for students who are first using these concepts. So now what happens if we offshore? Well, again, we want to think about our relative price, right? So the slope of the line that's tangent to both our PPF and our isoquant, right, not our indifference curve anymore, but our isoquant, right, the slope of that line is the price line. And remember, it's the price of X, right, the price of components, over the price of Y, and the price of R&D. Right? Now, we're saying the way we set up the model when we started off, we said that, look, because the home country has a higher relative wage for less skilled workers compared to foreign, that we're going to end up offshoring the less skill-intensive stage of production. Another way to think about this is when we open up to trade, what we're going to see is that our relative price of components is high relative to the international price or the world price, relative price of components. And so what does that mean if the relative price of components, and when we open up to trade, so for the home country, PC over PR&D is high, and so that's for home. And this is the world price, right? So when we open up the trade, what's going to happen? Well, the relative price of components is going to have to come down, right? It's going to come down to meet the world price. Here we're assuming small country, so anything that we do in the home country doesn't affect world prices. Even if we relax that assumption, yes, what we do have, the home country does, will have some effect on world prices, but we still get the same general pattern or prediction that the relative price of components in home will have to come down. And so how do we reflect that in our graph? So if PC over PR&D is coming down, that means that our price line is getting flatter. And so now when we look for a point of tangency between the price line and our PPF, it might be up, say, somewhere like here. So what do we end up doing? We initially, we produced this level of components and this level of R&D. Now we're increasing our production of R&D and decreasing our production of components. And we end up, just like before, right, when we were talking about using this PPF model with indifference curves, right, when we were talking about any of our three trade models, right, we were saying you can now produce on your PPF, but you can trade along the world price line. And so what does that mean in this case? Well, that means what we're doing here is that we're producing here, and then we're going to trade R&D for components, right? So in other words, we're going to export R&D and import components. And we might end up, say, somewhere like here, which is on a higher isoquant. So we're getting larger output, okay, Y1. And so this is our consumption of R&D and components. Right? So we're producing this much R&D, but we're consuming down here. So what is this difference? Right? That is our exports of R&D. And down here, we're consuming more components. We say consume, using more components to produce the final good than we're actually producing domestically. So there's our imports. Yeah. So we can see we're on a higher isoquant. So the total value of output that can be produced of the final good for the home country goes up. Okay. So that's where we have our gains from offshoring or our gains from trade. So conceptually very similar to what we did before when we were talking about the Ricardian model or the Heckscher-Ohlin model, right, showing that there we got to a higher indifference curve. Here we get to a higher isoquant, showing that, right, domestic output, total output increases. Now what happens if the terms of trade change? Right? Remember, the terms of trade are the price of the exported good over the price of the import good. So for the home country, because the home country is exporting R&D, right, the terms of trade are the price, right, price of R&D over the price of components. So first, let's take a look at a scenario where the terms of trade improve. Okay? So they work in favor of the home country. So again, we'll keep R&D up on the y-axis, and we'll put components on the x-axis. We have some initial, right, there's our PPF. I'll go ahead and draw the point for the autarky equilibrium, but I'm not going to draw the initial isoquant and all that because it'll just clutter up the graph here. So instead what we'll focus on is the initial outsourcing or initial trade equilibrium where we're specializing in production of R&D, okay, and we're getting, so I'll keep this, I'll call it Y1. Okay, so Y1 represents our output under some initial free trade scenario. So what we have here, right, our Y1 here. And now think about what happens if the terms of trade improve, right? So if the relative price of R&D globally goes up, what's going to happen? Yeah, it's the same as saying that the relative price of components goes down. So that's going to make our world price line even flatter, which means we're going to specialize even more in R&D production. Right, so we're going to move from our QC1, QR&D1 up to higher level of R&D production and a lower level of components production. Okay? And we end up on an even higher isoquant, call that Y2. Okay? So when the terms of trade improve, we specialize even more in the production of R&D, and we end up producing an even higher quantity of the final good. So what happens is our level of utility or well-being in society will increase because our national income will increase as we produce more of the final good. Now, what happens if the terms of trade go against the home country? So now instead of having the relative price of R&D go up, relative price of R&D is going to go down. And so let's take our same starting point. Some initial point in our PPF. So there's our autarky point, and we're producing here initially in free trade. And so I think there again is our QC1 and our Q quantity of R&D 1. So again, this all represents here our production of the two inputs, the R&D and the components, and our production of the final good under free trade with our initial world prices. Now, how would we show a fall in the price of R&D? Well, a fall in the price of R&D is the same as an increase in the relative price of components. That means that our world price line is going to get steeper. So we end up moving to, say, something like this. Okay. And maybe we end up over here. Okay. Now, where are we? We end up producing more components and less R&D when the relative price of R&D falls. But note that we're still exporting R&D and importing components. We're just going to be doing possibly less of it. And it looks like, right, our level of final output has decreased, and it has. But if we want to draw some kind of conclusion about whether offshoring in the end is, say, bad in a kind of overall sense of final output for the economy, you can't just compare Y2 to Y1. Now we have to go back and we'd have to draw in our isoquant that we had in autarky, that Y0. Right? And what's important to note here is that Y2 is still higher than Y0. So when the terms of trade decline for the home country, and when the relative price of the export good falls, overall level of well-being will likely decline, right? We'll see a decline in the output produced by of the final good in the home country, which would mean a decrease in national income. But we're still better off than we are in autarky. Now, to really convince yourself of this, you should think about a scenario where the terms of trade decline so much that it actually causes us to switch our specialization. Right? So I think about practicing that at home, and I will cover that scenario in class.